Welcome to the session called Cloud ODS with Microsoft Fabric, subtitled The Resurgence of the Operational Data Store. My name is Andreas Bergstedt, and I'm a Microsoft Data and Analytics Global Black Belt. The agenda of this session is in 4 parts. The first part is a brief overview of Microsoft Fabric, followed by the Operational Data Store and Application Architecture overviews. Then we're going to dig into the Microsoft Fabric Cloud Operational Data Store solution, and then some closing thoughts around what the solution brings and how the landscape has changed. Let's take a quick view at Microsoft Fabric. Microsoft Fabric is the unified data platform for AI transformations. It is built on three core principles: an AI-powered data platform. Here we mean a complete data platform, unified and classified, secured and governed. Our open and AI-ready data lake provides our core OneLake polyglot SaaS data lake, multi-cloud capabilities, and we're open at every tier. And the last pillar is AI-enabled business users. And by this we mean it's for every business user. No matter who the data citizen is, there we see all business users as data citizens. We provide access into Microsoft 365, as well as capabilities that can be published into the M365 Copilots in ecosystem. Microsoft Fabric is a set of serverless compute that operates on top of a unified data lake called OneLake. We also in the core have AI capabilities such as AI copilots that help you build up your data integrations, analytic workloads, troubleshoot your databases, and even help you with things like ML integration for real-time intelligence, and also help you build your Power BI visuals. We also have central governance in the Purview Hub in Microsoft Fabric, where you're able to set policies and govern your data estate centrally. Let's move on to operational data stores and application architecture. Since the beginning of multi-user applications such as ERP, CRM, TMS, and ITSM application, there's always been a need to display operational dashboards to monitor phone queues, stock levels, and team performance and general ops. This requirement has in most cases come with complex technical implementations, from managing database server performance so that the operational dashboard don't sync the application, or managing scenarios that need to span across systems, creating complex and expensive patterns that compromise on quality and reliability. One of the integral patterns that have always been central part of the enterprise data architecture that's aimed to solve this has been the operational data store. Some of the core values of the operational data store is to generate a database consolidation, data layer integration for your analytical workloads, and most importantly, the operational reporting requirement. So let's frame this from a microservices architecture perspective. So here we have a typical microservices architecture. Each microservice can deploy and transact on its own and store only its own data in its own transactional database. This is highly scalable and extremely flexible when it comes to app development. But it causes some issues when we need to understand the whole picture. For instance, in this case, this might be a retail system where we need to have a full picture of the customer order history or shopping behavior. In this microservice scenario, what normally happens is that we hang an enterprise message bus behind the microservice, where each service will publish its own transactions. So what we're now left with is a streaming data source like Event Hubs or Kafka, where we publish all our data. In order for us to consume this data for a dashboard, we need to aggregate and transform this data into a common layer fit for consumption. Our first challenge is that we need to process all of the stream data. Here we introduce complexities such as throughput pressure and schema management. We also need to have a historical reference loop so that we can handle change markers, key management, and general filtering. Once we have this, we then need to store this data and ensure that we can manage inserts, updates, and deletes. And at this point, we have introduced multiple engineering processes and complexities, and we haven't even started looking at the consumption layer yet. It is easy to see that we're increasing points of failure and latency into the design. And we're also starting to create processes that are not fault tolerant. For instance, if we need to reprocess our data from our data stores due to an outage or just backup pressure or data corruption, we then need to reship the data from the application database as the streaming environment has very short retention periods. And this normally also means that we need to cater for duplicate data, etc. This also applies to when we have back pressure, when we have an increasingly amount of data coming through that is unexpected. And I have seen in past implementation how this can cause data loss and consumption delays in downstream processes. If we now try to take this into the traditional context of the operational data store, we can see that the batchy processes and patterns that are common to an ODS no longer serves the microservices architecture. When we look at the Microsoft Fabric ODS architecture, we can see that it combines the best-of-breed patterns in Azure and Microsoft Fabric. It provides a low latency operational data store that serves both the traditional operational dashboards and the modern agentic application paradigm. It is broken up into three distinct layers. The first boundary is our secure on-premise and multi-cloud application database replication, where we provide transactional replication into Azure over secure supported corporate network boundaries. We support both SQL Server and PostgreSQL. And this layer also obeys the golden rule of no ETL against production databases. The second boundary is our network isolated fabric landing space. Here we secure and standardize data with low latency database mirroring in Microsoft Fabric. This enables us to have a single query layer where customer data can be accessed and consumed downstream. Then finally, we have our third boundary, and this is our consolidated consumption-ready operational data store, where we can serve agentic data analytics, app and API layers for in-app integrations, SQL analytics, and with the power of direct lake mode, also operational dashboards that are low latent. It's important to understand that the final consumption layer is all served through shortcuts, so no data movement has to happen through our standardization layer and our consumption layer. This also serves the final and third requirement of data integration, as not only is it operational reporting and database consolidation, but it also supports the integration layer into the wider analytical ecosystem of Microsoft Fabric. Let's take a quick look on how this would work in a proof of concept. Here we see our source database. This has got AdventureWorks 2022 loaded, or the lightweight AdventureWorks 2022 loaded. We have a job, a SQL Server job, that generates roughly about 1,000 sales transactions every 10 seconds. Here we can see the execution history of it and all the job runs. If we look at this query and we run this, we can see that we have data being generated roughly every 10 seconds, and we can see the volumes of rows. This data is also being replicated onto a SQL Server managed instance. And we can see that we have excellent replication performance with 6 seconds latency. Switching over to the managed instance, we can see our replicated AdventureWorks lightweight 2022 database, and we can see our sales order tables. If we look at this table, the table, we can see our transactional sales order data. If we now run the same latency query, we will be able to see our row count and our data age in seconds. And here we can see our data is 16 seconds, or 17 seconds late. If we run this again, we can see that we fluctuate between 12 and 10 and 70, or between 12 and 16 seconds. Moving over to Microsoft Fabric, we can see our replicated SQL database from our managed instance server. And here we can see the snapshots. We can here have a look at the SQL endpoint. And if we open up the same latency query, we can here see that our latency at the Microsoft Fabric landing zone is roughly about 50 to 30 seconds. We expect this value to always be under 2 minutes. If we look in the consumption workspace, we have a lakehouse called POV Analytics, where we have a sales order dashboard connected in direct lake mode. Again, here we can see a dashboard that is set to the last hour or last 2 hours of transactions, where we can see sales order transactions being refreshed and being available. As per the SOH in seconds, we can see that this normally stays below 2 minutes. Here we can also see a REST API that executes a store procedure. And here we can see our data assets latency. So here's 53 seconds latency. And our query performance is 170 milliseconds. We're also able to publish this or provide sample code on how to build this as an in-app data API for in-app experiences. We can also use our Fabric data agent to experiment with the data. And here we can write free text queries on our data to explore it. For instance, we can ask the data to give us some details about the last hours of transactions, see what product had the most sales. Here, the Fabric data agent are able to query our data lake and is able to return the right amount or the right product that had the most transactions, product ID 864. We can ask follow-up questions such as what customers have um, the most sales or the most product sales. And we can also expand the scope of our data agent to include data that we didn't have before, such as product categories, product descriptions, product models, and the joining tables. And here we can ask follow-up questions such as what was the description of the product ID 864? And here we can see that the data agent has answered correctly with a very strange product description, but we can validate that the answer is correct and that it has been able to solve the joins in the database environment. And here we can see that it's been able to analyze the environment to get the description ID and also been able to resolve it back to product description based on the product ID filter. If we now move on to the lineage view, we can now view this entire project end to end from our replicated database or mirrored database to our SQL endpoints, our data agents, our models, our dashboards, and our REST APIs. Let's conclude with some key takeaways. Microsoft Fabric in the Azure ecosystem enables a cost-effective and scalable data solution that breathes life into legacy concepts. Fabric as a low latency ODS enables in-app agentic experiences that serve even the most modern requirements. The implementation is low cost and has low overhead with no change required for the source applications or its hosting. For more information and more details, please visit my GitHub where you can run through this scenario end to end and build your own proof of concept. Thank you very much. Bye-bye.